Okay. All right, so for the first question, it gives us the equation of line 1 and line 2. It also gives us point A, and it's asking us to find point B so that this line, or so that vector AB is perpendicular to both lines. Okay, so the first step that I did is I know that the normal, so this line here, dotted with the directional vector of line 2 is going to equal 0. And so from this equation, I can find the Cartesian equation of the plane that's perpendicular to line 2. And so I find that the Cartesian equation is 2x plus y plus 4z plus d equals 0. And then I have to solve for d, so I plug in the point 5, 8, and -2 because I know that's on the line. And I solve for d, which is -10. So first step is done. I found the Cartesian equation for the plane perpendicular, that should say perpendicular, to the line 2. And now, for the second step, all I have to do is find the point of intersection between the line 1, which is this, and the plane that's perpendicular to line 2. So at what point would they meet? And at that point, it would satisfy, and vector AB would be perpendicular to both lines. So first step is I isolated for x, y, and z, and I came up with these equations. And then I plugged all of those points into the Cartesian equation, and so that way I can solve for t. And so I just FOIL in, and I gather like terms, and I end up coming up with the equation t equals -2/7. So then finally, I plug t into these equations to solve for the points, and I just FOIL it in, and then, or I multiply 2 by -2/7, add fractions, or subtract fractions, sorry, by finding common denominator, and I get 17/7 for this point. I get 12/7 for y, and I get 6/7 for z. So I know that the point of intersection is 17/7, 12/7, and 6/7. So therefore, point B must be that point in order to make the vector AB perpendicular to both lines. And question 2. So question 2 is asking to find the magnitude of B. And first off, I know that u dot v is going to equal 0 because it says right here that u and v are perpendicular to each other. I also know what vector u and what vector v are, so I can plug that in, and then I expand. So I keep going down until I get to this equation where I have 3a magnitude of a squared plus 10a dot b minus 8b squared. And so also in the question, it gives me that the magnitude of a equals 2, so I can plug 2 right into the equation. And it also gives me the angle between a and b is 60 degrees. So I know that a dot b is, another way of saying that is the magnitude of a times the magnitude of b times cos of the angle between them. So I know the magnitude of a is 2, and I know the angle between them is 60. So I plug those in, and then I simplify, so I get 12 plus 10 times the magnitude of b minus 8 times the magnitude of b squared. Or sorry, minus 8 times the magnitude of b squared. And then I reduce that, I rearrange that, and then I reduce it. I factor out -4 until I get this equation. And then I notice that this is just a regular a quadratic equation where I can just solve by grouping or factor by grouping until I get the magnitude of b would equal -2 because it's in the brackets different, and the magnitude of b also equals -3/4, but I know that it can't be -3/4 because it has to be greater than 0. It can't be less than 0. So the magnitude of b is 2. All right, finally, this question gives us the equation of a sphere in R3, and it gives us the center point of 1, 2, and 0, and the radius of the sphere is √6. So the first question's asking, it gives us a point on the diameter, and it's asking us to find the point on the other side of the diameter. So to do this, I realize that the equation of this line right here is going to equal, here's the starting point that I use, and the slope is -1, -2, and 1. And I found the slope because I know the center point and I know this point, so I can just calculate the rise of the run, or the change in the x and the change in the y and the change in the z. And then I know that to find this equation, or to find this point, it's going to be a, b, c. It's going to have values a, b, c. And so I just set that I have to find out when a, b, c equals this line. So I isolate for a, b, and c using parametric equations. And I know that using the length of a line equation, I can solve for t, because I know t will be the only equation remaining, or only variable remaining. So the equation is the x2 minus x1 squared plus y2 blah 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 equals the length of the line. And I already know that the length of the line is 2 root 6, because the radius is root 6, so 2 root 6 would be the diameter. And then I square both sides to get rid of the square root on both sides. And then I plug the parametric equations in to get t as the only variable. And then from there, I can simply realize that these will cancel out. 2 and -2 will cancel out. It'll leave me with -t squared. 4 and -4 will cancel out. -t squared, or -2t squared. And then 1 and 1 will cancel out, so it leaves me with 2t squared. And then simplify that. I get 6t squared equals 24. And then solve for t. And so I get t is equal to +2 and -2. So my last step is find the point and find out if it actually lies in the line. So I plug t into the equation of the line and find what the point would be. So when t equals 2, the point is 0, 0, and 1. So to find out if that point lies on the sphere or on the diameter, I plug it back into the equation of the sphere. And so that equals x minus 1, blah, blah, blah. Sorry, it already gave you the equation. So I plug in 0, 0, and 1, and I solve. 6 equals 6, which makes sense. Therefore, this line lies, or this point lies on the line, or in the sphere. So also have to try this for -2. Plug it in, I get the point 4, 8, and -3. And I plug this point in to the equation of the sphere, and I get 54 equals 6, which doesn't make sense, therefore it doesn't lie on the line, or on the sphere. So after I did all this work, I realized that an easier route is to use the slope that I found from the end of the diameter to the slope, and just do the same thing to find the other half, because it's the line's the same length, therefore it's going to be making the same movements. So here I get 2 to 1 is -1, so 1 to 0, or 1 to 0 is -1. So 1 minus 0 is 0. Sorry, 1 minus 1 is 0. 4 to 2 is -2, so 2 minus 2 is 0. And then -1 to 0 is +1. 0 plus 1 equals 1. So that just proves that this will be the point on the other end of the diameter. For question B, it simply asks for the Cartesian equation of the line parallel, or of the point parallel to, let's just say this is a good picture of the line, of the point 2, 4, and -1. So find the Cartesian equation of the plane perpendicular to the point 2, 4, -1. All I do was I have the line, the equation of the line. I use the directional vector to find the Cartesian equation, and I sub 2, 4, 1 in to find d, and then I change the signs around so that the a value is positive, and I get x plus 2y minus z equals, or -11 equals 0, which is the Cartesian, and that is my time.